Hello everyone, myself Govind Raman, currently pursuing my computer science and engineering degree in Sri Venkateswara College of Engineering with AI as my specialization. So my today's topic is about joint probability distribution. In this presentation, we'll be studying about what is joint probability distribution, what are discrete random variables, and what is marginal probability distribution. And we'll be further studying about the covariance correlations part, and we'll be looking about the important formulas in joint probability distribution, and we'll be solving a simple problem on joint probability distribution. Finally, applications of joint probability distributions. First, let us get to know what is joint probability distribution. A joint probability distribution is a distribution having two or more independent random variables in a joint distribution where each random variable will still have its own probability distribution, expected value, variance, and standard deviation. In addition, probabilities will exist for ordered pair values of random variables. Furthermore, the strength of any relationship between the two random variables can be measured. Most often, a joint distribution having two discrete random variables is given in a table form. In this situation, the body of the table contains the probabilities for the different ordered pairs of random variables, while the margin contains the probability for individual random variables. For example, consider two random variables, that is x and y, where x represents the outcome of a coin toss, which is heads or tails, and y represents the outcome of a rolling six-sided die, that is 1 to 6. A joint probability distribution would assign possibilities to events like heads and 3, tails and 5, etc. So, what are two discrete random variables? Discrete random variables can only take on a countable number of values. A single RV, that is random variable, can describe one random event. Two RVs, that is two random variables, describe a pair of events. Example, if we toss a coin twice, we can describe the number of heads in each toss with two random variables. That is RV. So moving on, what are marginal probabilities? If more than one random variable is defined in a random experiment, it is important to distinguish between the joint probability distribution of x and y and the probability distribution of each variable individually. The individual probability distribution of random variable is referred to as its marginal probability distribution. In general, the marginal probability distribution of x can be determined from the joint probability distribution of x and other random variables. If the joint probability density function of random variable x and y is f of xy, the marginal density function of x and y, which defines the marginal distribution, is given by f of x is equal to integration of f of xy dy. F of y is integration of f of xy dx. What is covariance and correlation? Covariance measures the degree of linear association between two random variables, whereas correlation is normalized measure of a linear association that ranges from -1 to 1. So remember, the correlation of x and y will always range between -1 to 1. Example, if we measure the height and weight of a group of people, we can calculate their covariance and correlation. Further, let us see some important formulas of joint probability distribution. Suppose a joint distribution of a random variables x and y are given in a table form so that p of capital X, that is equal to small x, and y will be equal to small y, typically abbreviated as p capital Xy of x comma y, is given for each pair, that is x comma y, of random variables. As with all discrete distributions, two requirements must hold for each pair. As you can see, summation of p of xy is equal to 1 for all values of x and y. Then the marginal probabilities of p of x and p of y, the expected values of e of x and e of y, and the variance of x and y can be found by the following variables. As you can see, the formulas of p of x, p of y, expected value of x, expected value of y, variance of x, variance of y, and you can even see the covariance formula, To measure any relationship between two random variables, we use the covariance. That is, covariance of xy will be summation of xy p of xy minus expected value of x into expected value of y. However, the covariance will have the same units as variance, as as is therefore affected by unit chosen to measure the data. Therefore, we also define correlation which is unitless, that is rho of xy. The correlation will be covariance of xy divided by sigma x and sigma y, that is standard deviation, which we'll calculate earlier. Moving on, let us see some example problem. An apartment manager decides to see if timely payment of rent is related to unpaid credit card balances, using X as the number of unpaid credit card balances and Y as the timely rent payments in the last 4 months. He examines his record and the credit reports of his renters and obtain the following results. As you can see, the data is given in the table form, where the upper part is x and the left side part is y. The first we'll calculate marginal distribution and then the expected value, that is e of x. We can see the formula for e of x is x into p of x, and e of y, that is y into p of y. As you can see, e of y, the y value is 0, the corresponding x value will be 0.1. So summation of all x and y is done to calculate this expected value of y. We can also use the formula to compute the variance and standard deviation of each random variable, where variance of x will be x square p of x square minus expected value of x square, and variance of y will be summation of y square p of y minus expected value of y square. After getting variance of x and y, we'll be looking into the next part, which is to calculate covariance. As we studied earlier, the formula of covariance will be summation of xy p of xy minus expected value of x into expected value of y. We'll take all the values which we calculated earlier and we'll add it. That is, the summation symbol means you have to add all the values of x and y. You can see the covariance which we get final is minus 0.5547. Since the covariance is non-zero, the variables are not independent but do have some sort of relationship. Since the covariance is negative, the relationship is inverse relationship, where the increase in credit card balances generally decrease the timeless of rent payments. But to determine the strength of relationship, we evaluate the correlation. The correlation formula will be covariance of xy divided by sigma x and sigma y, that is standard deviation. We'll get minus 0.4329. We find that there is a moderate negative relationship between the number of credit card balances and timelines of rent payments. Moving on, applications of joint probability distribution. You can see joint probability distribution is used in various fields, like in data analysis. Probability distribution plays an important role in statistics data analysis, as it allows us to make inference about a large population based on small sample. It is even used in finance. It can be used to analyze investments and calculate the expected return of a portfolio. Weather forecasting, probability distribution are also used in atmospheric science to develop weather forecasting models. Thank you.